Okay, so the task says on R1, ensure BGP is brought down immediately when link is down, and then enable BGP graceful restart. Graceful restart is when the BGP is restarting, it will restart without disrupting neighborship information. The BGP will restart. eIGP has the same feature. BGP eIGP graceful restart. Graceful restart is basically means I'll restart my neighborship without bringing the session down, without interrupting the section. And then allow up to 32 equal cost paths for both iBGP and eBGP. Change administrative distance for internal, external, and local. We are changing the administrative distance for external, internal, and local to 19,119. You know, BGP, the external BGP has an administrative distance of what? 20. And then the internal is 200. And the local is 20. So we are changing the external to 19, the internal to 109, and then the local to 19. So we are doing all this task. So the first task, BGP section brought down. A simple router, BGP 65013. The command is BGP fast external, immediately reset session if a link to a directly connected external peer goes down. So this is the command we need, fast external failover. It immediately resets session if a link to a directly connected external peer goes down. So this is the command that we need. And then we'll simulate and see. So that is a BGP external failover, is to reset the BGP section when the BGP section is brought down immediately when link is down. So that's the command that you need to do, BGP fast external failover. And then also, it said enable BGP graceful restart. That command too is simple. It's BGP graceful restart, gracefully restart capability parameters. So this is the command that we need. Hit enter. All BGP sessions must be reset to take the new graceful restart. So we have to reset the BGP section. Do clear IP BGP star. And I'm doing a hard reset. You see the section, all the section has reset. See, BGP section has reset. This is a hard reset. Don't do this in production environment. Don't do this in production environment. If you do this in production environment, Master, your boss will worry you. So on how to, let me try and shut down the serial link and see. Interface serial 2, is it 2/0? Let me be sure. Do show IP interface brief. 2/0, okay. Interface serial 2/0 shutdown. Let me see. You see the command. You see neighbor reset, interface flap, down interface flap, Unicast topology base remove. So you see the section. So you see BGP section is up. It has reset the neighborship. You see notification 3, notification of BGP sent to all section. Neighbor is down. Neighbor 3 is down. Neighbor so is down. It's reset. So that's the command that we issued. The BGP fast external failover. So it's a very important command in your BGP, if you find yourself in your BGP settings, you can issue that command so that if a neighbor went down, the session state will reset. Let me bring it up. No shutdown. So the next command is allow maximum equal cost path for both BGP, iBGP, and BGP. Multi-path equal path, that is an equal cost path for BGP. The command is simple. On R1, we are doing all these tasks on R1. So BGP session is up. So we are still on R1. The command is maximum we have to go under the address family first. Address family, I tend to forget this thing. Unicast, maximum path. So that number of paths you can do for eBGP, you can do for iBGP, both eBGP and iBGP. So we are saying so we want to have 32 maximum equal paths. So what is this maximum equal path? I try to, I don't know how I will explain it to you. So Lex, I don't know how I'm going to explain this thing to you. How am I getting this? So BGP maximum path. So the maximum path command allows you to configure BGP to install multiple paths. So that's in the RIP. The RIP is the routing information base. The routing information base is what you see. The routing information base is do show IP BGP. This is the RIP table. This is the BGP RIP table, routing information base. This is the RIP BGP RIP table. So the maximum path allows you to configure multiple paths. This is a small topology, but if you are doing it in a very bigger environment where you have a lot of BGP speakers, BGP router is the same as BGP speakers. That is where this command is very useful. But this is a lab, so we want to explore all the features. That is why we are doing this. But it is very useful in a very larger BGP environment. So maximum path is 32. We want to do the task say do 32. 32 equal cost path for both iBGP and eBGP. And then we'll change the administrative distance for eBGP, iBGP, and then local. My particular interest is in the filtering. So let's be very fast and get to the filtering part. That is where the fun part is. So the maximum part has been configured. We have to change the administrative distance. It's very simple. You use the command distance. So the distance, this is for administrative distance. We are changing the administrative distance, but we want BGP instance. So BGP instance, distance for route external. This is eBGP. And the task scale, we should change it to what? 19. We know eBGP is 20. The AD for eBGP is 20. So we are changing it to 19. So 19. And then this is for internal. The internal is 200. And the task say we should change it to 199. And then this is for local route. The local route, we are doing what? 19. So that's all. This is the command for changing the BGP distance and everything. I hope, okay, we are recording, so, but I'll try as much as possible to write all the commands down and then send to you on the platform. So task 1 is done. We are done with task 1. Any questions so far? We are done with task 1. So we are on task 2, maximum preface, keep alive, hold time, and authentication. Any question? Any question? Should we continue? Hello? Should we continue?
I think we can go on.
Hello.
Hello.
Should we continue? Any questions so far? Should we continue to task 2? Hello.
Yeah, Echo.
Yeah.
Yeah, if you can quickly go over the equal cost path.
You said
path.
I can't hear you. Your line is very bad. John.
Can you hear me?
There's a your voice is very bad.
Can you hear me?
Yeah, I can hear you now.
Okay. I'll tell you to go over the equal cost path.
The maximum equal cost path. Okay, the maximum equal cost path is basically to allow BGP to have multiple paths to iBGP and eBGP. But in our case, we have a very small topology. So we won't see that the essence of that in the BGP table though. But for lab purposes, that is why we are doing it. But if you have in a bigger environment where there's a lot of BGP speakers, you have BGP will have a multiple path though. If you have like redundancy in your network, and one link phase, BGP will have a way to route the packet through the other links. That is the benefit of a maximum equal path, is to have BGP to have multiple paths in its routing table for iBGP and eBGP.
Okay. So this is path, different paths to say same destination.
Your line is very bad. Your speaker is giving me distort feedback.
Oh,
Am I the only one who can hear the distort in his voice, or anyone else can hear that?
Echo.
Yeah, it's better
Is it?
now. Now it's clarity. There's clarity.
Oh, that's
Okay.
fine. So the equal cost path is just alternate paths to say the same destination.
Yes, for eBGP, and like I was checking from the internet, the maximum path command allows you to configure BGP to install multiple paths in the routing information base for multi-path load sharing. BGP uses the best path algorithm to select a single path as the best path and advertise the path to there. So it's like you are load balancing. You are load sharing your I don't know you are advertising in this case when you have like you're connected to more people and you are sharing your if in this case like here we have on R1, we did it on R1. If R1 has a link to another, let's say this is an ISP, and we have another link to another ISP, and we have the equal multipath section here. We have another link to another iBGP. We'll be sharing our load across. The multipath allows us to share our load across. But in this case, we have only one route, one link to R2. But for the lab purposes, we are using it. I hope you understand me now. Assuming we have for load sharing, we want to share the load. That is why we bring in the maximum equal cost path. But in this case, we have only one. Okay, so if like we have multiple links, we will be sharing our load across. That is for the multi-path equal cost path for either iBGP or eBGP.
Okay.
So any question before I move on to the next task? Are we all okay? Are we okay? Are we all okay? Are we okay?
Yep.
Can I
Yep.
continue?
Yep. Yes, you can.
Okay. Okay. So on task 2, we have maximum prefix keep alive, hold time, and authentication. So our focus for the task 2 will be on R1. R1 should allow a maximum of one prefix being received from R2. So R1 has a maximum of, should allow a maximum of one prefix to be received from R2. So in this case, let picture R2 as your service provider, okay? Picture R2 as your service provider, and picture this side as your enterprise network, and this is your border router. These are your internal routers, and you want to allow a certain preface from your ISP. You don't want your ISP to push you all the internet route. You want to allow certain prefaces from your ISP. So the task say that on R1 should allow a maximum of one prefix being received from R2 and produce warning when this is exceeded. Okay, so we can verify by advertising R2 loopback 1 in BGP. So that is the task we're going to do. And then we will do from that, we'll go to lower keep alive and hold time on R1 to 10 seconds and 30 seconds respectively. Enable authentication between R1 and R2 using the password of Cisco. I hope the concept, what the lab is trying, the lab wants us to achieve is clear here. Picture this, like I said, picture this as your ISP and this as your border router in your network. You want to allow a certain prefixes from your ISP. And if that prefix, if the number of required prefixes that you want to receive from ISP exceed, you want to produce a warning. You want the router to generate a warning that, hey, if you reach the number of prefixes that you want, you have to receive from your ISP. So that's the task that we are going to do. So we'll go on R1 to execute this task. So we'll go on under the router BGP 65013. 65013, address family IPv4 unicast. So we are saying neighbor, this task is to allow, we want to receive a certain prefix from R2. So the command will be applied to our neighbor, the neighbor that we want to receive the prefixes from. So it's neighbor 172.16.12.2. And then let's see the option that we have. Maximum prefix, maximum number of prefixes accepted from this peer. So we want to define a certain prefixes or route. I'll be using the words interchangeably. Okay, the same as route. Prefixes or route. That we should be receiving from, so the maximum prefix, number of prefixes are accepted from this peer. 1 minute. Hello. Hello. Hello.
Yeah, hello.
Yeah,
Hello?
I'm back. Okay, so the task say we should allow only one prefixes from R2. Okay, so the command is maximum prefix. The maximum prefix, and then we have to, it said we should have, it should be 1, right? 1. Okay. Is that not what the task says? It said we should only receive one prefix from R2. Okay. And then we want to produce a warning when this prefix exceed the maximum that we are expecting from R1. You can generate a threshold. You can do a restart connection after limit is exceeded. You can do restart. So meaning if the limit exceed, but you won't do that in a production environment. You have to restart. No. So if the limit exceed, you restart the neighborship or produce a warning. So the task say warning. So produce warning, then you enter. Now we've done that. So you see, we are getting a message. Number of prefixes received from R2, which is 1, maximum 1. So you see, we have received the number of prefixes. It's not 1. So show run, show iBGP unicast. Let me show iBGP unicast. Unicast. So iBGP so we don't have unicast here. Okay, so iBGP So this is what we are receiving from R2. Part is 2. We want to receive only 1. We don't want to exceed. So the task says it should produce warning when it exceeds the task. So we have to verify by advertising loopback 1 into R2. So let's go to R2 and then we advertise loopback 1. Loopback 1 is 2.0.1. Okay. So router BGP to address family IPv for unicast. Network 2.2.0.1. Mask is what? What is our mask? Is this last 32 or? It's last 32, right? 255.255.255.255. We should get, you see, we've gotten a message. Maximum prefix exceed. BGP syslog 3, maximum prefix exceed. Number of prefixes received from 172.16.12 to exceed limit 1. So we have successfully configured what the task is requiring of us. We have verified and it's working. The number of prefixes has exceeded and it is throwing us a warning. So this section of the task is done. The next section is this side. Okay. So let me undo it. No, this. Okay. So the next section says lower keep alive and hold time on R1 to 10 seconds and 30 seconds respectively. So I hope we all know keep alive. Keep alive is if we don't hear from your neighbor for some certain seconds, you presume your neighbor is dead. Keep alive is, we all know what keep alive is. So the task says we should lower keep alive and hold time on R1 to 10 and 30 seconds respectively. So still on R1, we'll still go another BGP section, 65013, address family, IPv for unicast. Neighbor, we apply it to our neighbor. Neighbor 172.16.12.2, and then we're looking for timers. It says we're on the wrong interface. Neighbor 172.16.12.2. Okay, so timers, this is what we are looking for, BGP per neighbor, BGP per neighbor timers. So this is the timers we want to reduce to keep alive. The keep alive is 10 seconds. And then the whole time, this is the whole time, we are tuning it to 30 seconds. This will make your BGP section to come out very fast. The timers and then the whole time, the number of times that I have to hold on before I inform my neighbor, I assume that my neighbor is down. By default, is BGP is, I think, 3 minutes or so. Yeah, it's 3 minutes or so. So 90 seconds, it's 90 seconds, yeah. 90 seconds or so, yeah, that's the default. So we are fine tuning it to 30 seconds. So the timers have been tuned. Enable authentication between R1 and R2 using the password Cisco. So we have to enable authentication between R1 and then R2. How do we do that? So do show iBGP neighbor. So this is our neighbor. So you see the whole time is 180. It's 180 rather. Whole time is 180. And then keep alive interval is 10 seconds. We have configured keep alive interval is 60 seconds. Configured hold time is 30 seconds. So we have configured the whole time to be 30 seconds. Keep alive interval is 10 seconds. So for this to take effect, we need to reset the BGP section. Do clear iBGP star soft out. We have reset the BGP section. So let me check again. Let me reset here. Clear iBGP star soft out. So iBGP neighbor 172.16.12.1. So we have our hold time to be 30 seconds, and then we have our keep alive is to 10 seconds. But when you check here, it is not configured here, so it is keeping the default. The default is 120 and then 60 seconds. it is keeping the default, but on R1, because we have manually configured, we are seeing hold time to be 30 seconds, configured hold time to 30 seconds, keep alive 30 seconds, 10 seconds respectively. So we have to enable authentication between R1 and R2 using password of Cisco. So we'll go under that and then enable authentication. We are still under BGP. So address family, IPv for unicast, neighbor, no, it's supposed to be neighbor 172.16.12.2. What we are looking for is password. So password of Cisco. So we want authentication. It is ideally that in your network, you must enable, for security purposes, you must enable authentication on all your peers, all your BGP peers. Not only in BGP, you can do that in OSPF, you can do that in ISIS, you can do that also in eIGRP and RIP. I don't know if RIP is still existent, it's being used in network nowadays. So the authentication is password is Cisco. Okay,